Hello and welcome to our webinar today. Microservices and PCI. I'm happy to see you all joining today. I'm happy to see quite a few familiar faces, at least virtually, and I hope you're healthy. And today we want to talk about microservices and how they relate to PCI. What can you do, or what do you need to consider if you want to implement a microservice architecture within your PCI environment? What are the PCI requirements you want to look out for? And so that's a quite interesting topic. That's a topic that has been requested for the last 12 to 18 months by a lot of customers who want to make the switch and who want to kind of go forward within their architecture, within their technology cycle. So I'm happy to help, and I'm happy to share experience we gathered so far, and hope this will help you at the end of the day. As always, you have the ability to ask questions. On the right-hand side, you should see some kind of chat box where you are able to provide questions, and these questions will be forwarded to me by my lovely colleague. And as always, I try to answer these during the slides if they are applicable there, or at the end we always have some kind of Q&A sessions for a couple of minutes if there are questions, and if the questions are a little bit too specific for this context, then feel free to reach out to me or my colleagues, your QSA, then we can take this offline. My name is Jan Kemper. I'm a QSA for USD for at least 5 years now. I'm IT security expert as well, and I'm helping our customers to migrate to the cloud or to a microservice architecture. Usually this goes hand in hand, and so I'm looking at everything from a PCI compliance point of view or a general compliance point of view, looking at things from a IT security point of view, but I'm not a DevOps guy. I'm not a reliability engineer. I'm not here to make sure you have 100% uptime. I'm no expert on that. There are a lot of other people that can help. I'm only here to talk about microservices from a PCI point of view, and please keep that in mind today. So we always have to simplify a lot of concepts here, but at the end of the day, I think you know that, but it's always good to reflect on that. As a surprise for you, I will also give you a quick update on the PCI 4.0 timeline, because that was an article published last week, at the end of last week, I think, by the PCI Council. And as probably most of you are somehow in the process or involved within PCI certifications, you're probably wondering when you will need to switch to the 4.0 standard. And I'll take 3 or 4 minutes out of this webinar to give you an update on that. And basically after that, we try to start with a quick introduction, like get a baseline understanding of what are microservices, what are clusters, why would you use them, and why maybe you won't use them, or why they are pretty difficult or not difficult if you want to use them in some kind of compliance framework. And as I already mentioned, we hopefully have time for some quick Q&A at the end. So let's start with the 4.0 timeline. And here we can see basically the current state. So last year at the end of October, I guess, there was the 4.0 draft. The first draft was published to all auditors, all QSAs, and we were able to provide feedback within 3 or 4 weeks to the PCI Council. We did that. There were quite a lot of updated requirements, quite a lot of new requirements. The structure has changed, so there was a lot of internal discussions before we gathered feedback and posted that to the council. And I think other QSA companies also had a lot of feedback on that, because the second draft was postponed to September, October this year. And after that, we will have another chance to comment, and we will probably have a good idea and understanding what requirements will be there in the end when the final version will be released. And so maybe if you're already interested, we probably have a good idea where things are heading at the end of the year. So if we want to have maybe a couple of workshops on some of the initial requirements that we think will stay and will be applicable to you, we can do that, or we can wait until the end of Q2 2021, where PCI 4.0 should be published as of right now, and at the end of 2021, all the supporting documents, that also includes SAQs, should be published according to the PCI Council. So this is the rough timeline for the next 1.5 years. But what's more interesting for you is the transition timeline. So when do you actually have to be compliant against PCI 4.0? And we see a transition period of 2 years, 24 months, starting with Q2 2021, and then probably PCI 3.2.1 will be retired at the end of Q2 2023. So if you're in the current audit cycle for this year still, you will definitely have the chance to do at least 2 more cycles against the current PCI DSS framework. And then somewhere in 2023, I think you will need to switch to 4.0. And also there will be some new best practice requirements. So requirements that are future dated and will be included in the 4.0, but will have a date attached to them, and apparently it will be something like beginning of Q2 2024. As of right now, we don't know which requirements will be future dated, but hopefully this is something that will be then part of either the draft version or the finalized 4.0 version. So overall, I think the biggest takeaway here is you will have security that next year you can still do your PCI assessment against 3.2.1. You will have then, after the next year's assessment, probably you should start addressing 4.0, start addressing the new requirements, start addressing the updated requirements, and then depending on how that goes in 2021, we can decide against which requirement or which standard you will be assessed. But then in 2023, you should have your 4.0 requirements ready, and in 2023 begin to assess against 4.0. So that's the quick summary for the timeline. I hope that clarifies a lot of things. If there's any updates coming through by the PCI Council, we will update you. You can always follow our social media or our websites, and if there's a bigger announcement, we will also do a follow-up webinar on that. So we hope that we are able to inform you about any changes regarding 4.0. So now let's get started with the topic at hand, microservices. And if we take a look on basically the technology we are working with, the various vendors that are bringing out technology that should support you within your microservice adventures, we see that there's like 100 solutions, hundreds, maybe thousands, I don't know. They all try to tackle the problems and try to address the problems of microservices, of microservice orchestration, of managing orchestration layers and stuff like that. This is pretty usual. If there's a new technology coming up, there's no best of breed yet. So a lot of technology will be there in the beginning. A lot of technology will be retired, and some of these will basically push through the top, to the top, and will be there at the end of the day. As of right now, we have to live with these. What we usually see, or what is the most prominent, are probably like Docker, Kubernetes, and OpenShift. What we see in production networks being used right now, and also the cloud providers that are on the slide, they are also offering managed Kubernetes. They are offering maybe something like ECS, Elastic Container Service, within AWS. So it's basically a lot of technology we need to work with, a lot of technology we need to think about, and a lot of technology out there. So it's kind of complex from your point of view, from our point of view, and we really need to deep dive into the technology to understand it and to understand the difference between each one. In order for us to today talk about microservices and PCI, we need to have a quick alignment on like the basics on microservices, how they work, where they're coming from, to get an idea and to better understand the concepts, how they interact with PCI. So for the next couple of slides, I will basically do some general introduction to microservices. Hopefully that's still interesting for you if you're familiar with that. Let's see. So in the beginning, there were physical servers. You had a physical server, you needed to procure physical hardware. Every physical server run their own operating system, and then on that operating system, you will deploy an application or two applications, depending on your use case. If you had a new application and you couldn't deploy it on existing hardware, you needed to get a new server. To deploy that new server, you needed to decide on the size of the hard disk, RAM, on different things. You need to think about it. Want I provision this for now, or do I want to provision this for 2 years in the future when my application will have more traffic and needs more resources? So there was kind of a guessing process involved. You never knew if your application would actually make it in the next 2 years. You had the time where you need to actually put physical stuff somewhere in the data center. So that was kind of cumbersome. So the obvious move was to move to virtualization, virtual machines, where you only had one physical appliance, and that physical appliance was able to run virtual machines, where you are able to define basically the percentage of resources that are being used from the server. So if you had a lot of small applications, you could provision a lot of small virtual machines, and if one of these applications would demand more resources, you had the ability to upscale that virtual machine without need to get new hardware installed, basically. So you had a lot of more flexibility, and that obviously helped to reduce costs at the end of the day, and that's basically where we are at today. And the next step then would be to actually take a look at how we are doing virtualization right now and think about how we, or some of you are already doing this, but how we will do this in the future. Maybe the best example is actually if you take a look at the left-hand diagram, you will see the operating system is actually being run 4 times. So each time resources will be consumed, some of these services will run 4 times. And the question is, do we really need that? Is that the most ideal situation, or can we reduce that? And obviously on the right-hand side, you see why do we need 4 times COS if we can run this once, and then only containerize, virtualize the application itself, but not the operating system. So that's where we are today, or today, tomorrow, where we say, okay, at the end of the day, we have an application. That application should support the business process, and we want to have flexibility here, but we don't have a business process that consists of running an operating system. So let's make sure we are only virtualizing our application. And on the next couple of slides, let's talk about some of the buzzwords I already mentioned here, the technical terms that are in place. And what you usually see is always the mention of images, container, and registry. So an image is basically some of the binary that includes all of the requirements for running a single container and metadata, basically. While the container is basically everything that you need to run at the end of the day, where you will have your image, your application, your configuration files, your libraries that are needed to run this application, where you will have this as some kind of runnable instance. And at the end of the day, you will find a lot of this within the registry, which is basically like a library of images and containers. Most famous one is probably Dockerhub. You will have a registry hub by Red Hat as well, and a lot of other companies that provide these services. You can have a private registry within your company. You can have an Amazon service that is a registry where you can publish your containers or images. So there's a lot of different stuff going on there. As I said, the most prominent is probably Dockerhub. Docker was one of the early technologies within the microservice space. I think it was founded in 2013, while some of microservice technology already existed beforehand, but the ball got rolling, I think, with Docker 7 or 8 years ago. How would this work in a simplified way? If we take a look here at the server and operating system on a single node, we would have a container runtime, and we had to have a registry we just talked about, where we can find different images in there. We can basically tell our container runtime to clone these images, copy these images to our local server. Let's say, for example, we want to run a web server like Nginx. So we would copy the image here, and then we would probably start this image with the needed configuration, and that would then guarantee that we have a container running with all the needed configuration on that server. And obviously, if we want to start a web server, we want to display content. So we may want to get a WordPress site up and running. Let's pick a WordPress container, for example, and start this up. Start 2 containers here on that server. And so at the end of the day, in this example, there was already an image on the machine of WordPress, so it didn't need to go to the registry because the versions, the tags were aligned, and the container runtime was able to start this from the local image. So this is very simplified how it would work, where you can start multiple containers, how the runtime would talk to a registry, but this is only on a single server. What a lot of people understand or think microservices are is if we are running microservices as a cluster. And this is where a lot of the magic comes in. And this is basically the example of Kubernetes, of OpenShift, which is quite similar to this. There's a lot of different orchestration technology out there, but let's keep it on that level. That's why you also see the master manager reference here. Everybody calls things differently. If you understand the concept, then you will probably understand and can translate this to different technology in that space. So we have usually 3 servers that are the master nodes, the manager nodes that are able to orchestrate at the end of the day. And then we have a couple of servers that are able to run the actual payload. Also, payload is obviously the containers that we want to deploy. These are usually called like the worker or node servers, depending on the technology you are using. Obviously, each of these are running an operating system, are running a container runtime, and they have communication established with the master and manager servers, and the master and manager servers are communicating to each other. They make sure they all know the state of the cluster. They all know where which container is running. So for example, if we take a look and we want to spin up a couple of containers here, we have a WordPress container running on 4, a web server Nginx on 5, and some DB on server 7. So what would be the magic here? Let's say server 4 would go down, and that's would be able to replicate the container, not replication. It would start up a new container on server 6 because the master or manager node is able to recognize that server 4 is not there, but knows that at least one WordPress container should be started at all times. So that container would be deployed to any other server, for example, in this here, server 6. So that's basically some of the magic why people want to run microservices in some kind of orchestration cluster, where the cluster is responsible for managing the containers and managing where the container runs, and what's most important, that a container runs, or that a specified amount of containers are running. And for example, what is also possible is some kind of scaling here, that if we say the traffic is increasing, then we could also always spin up like a second web server, second Nginx here to accept traffic. It's very simplified here, but we will come back to that later and look at the PCI implications. So why should you use that? So I was talking a lot about the different benefits maybe already, or some of the challenges here. So this is not a list that will be complete, but probably some of the ideas that you already have in mind, maybe your management has in mind, why you should use it. And what I think is one of the biggest plus is portability. So you're able to run this same container in dev, in staging, in prod. You can make sure that you have DC parity. You can throw the same container to different DCs. You generally shouldn't need to worry about special configuration for special locations, for special DCs, special cloud providers. You should be able to deploy a pod, a container to different OpenShift environments, for example, to different Kubernetes environment. It really doesn't matter. If that's the case, then you will also always have the benefit that the output should be the same regardless where you run this. So at the end of the day, this means you have better testing, you have better quality, you have less errors. So that should be a big plus. Then the next one would be agility. Obviously, if you have like some kind of monolithic application, one big Java application where you want to fix something, you want to add a feature, you always need to deploy the full application. If you develop this application in some kind of microservice architecture where you split the application in various small services, then you can fix or update each service independently, and you can deploy much quicker because you don't have to redeploy 98% of the application all the time. You only need to redeploy 2% of the application because that is their own microservice. So your development time from start of development to actually running in production should be way lower. Scalability and reliability is also something that's probably really interesting for you. It's not that interesting from a PCI point of view as of right now, but a couple of you are running e-commerce sites, are running backends for e-commerce sites, and during Black Friday, during Christmas shopping, doing some kind of special offerings, you will notice you have increased load. And if you have something like auto scaling enabled where you can just deploy more and more containers, then you will be able to handle that load way better than if you would use static or somehow static VMs. And then reliability. Most cluster orchestration technology has the ability to implement automatic health checks and implement automatic monitoring solutions where you can be sure that at least X amount of containers are running and you don't expect any downtime there. But what are the disadvantages? It's not all, it's obviously not all positive. It's not all of the features are beneficial for your environment. And like every new technology, the technology itself, the ecosystem is not that major compared to, let's say, classical hypervisor strategies using virtual machines and stuff like that. As I already said, I think Docker was published or was founded around 2013. And most of the microservice Kubernetes hype picked up probably 4 to 5 years ago, maybe even a little bit later for real production environments, maybe 2 or 3 years ago. But at the end of the day, the ecosystem is not that mature. So what that means is obviously this technology has not yet received the best tooling possible. There are a lot of tools out there, but maybe not the right tools. The best tools that have gone through iterations and iterations of improvements that help you to manage your technology, your environments out there. Yes, there's a lot of stuff available, but maybe it's not already feature complete, and you need to look out. The technology itself, I was looking at the published vulnerability for Docker or Kubernetes, I think yesterday, and there are not that many out there because a lot of technology is like based on the Linux kernel, and you are using features of that Linux kernel, which is quite proven, obviously, and very mature, but still, if you have vulnerabilities within your hypervisor layer or your container runtime layer, that could spell trouble, and you need to make sure that only because the technology is new and every software has bugs, every software has vulnerabilities, there maybe is something still out there which you need to consider. Traditional security measures may not be sufficient anymore. So we saw, or we know, that there's a lot of basically there's a lot. You need to think differently if you want to go to a microservice environment. Your structure will change, and so your traditional security measures may need to change as well. While in the beginning you were accessing your environment through a bastion host, SSH, using SSH, going in there and setting up servers that way. Today, maybe if you're using Kubernetes, you will do it that differently, and this is something we will talk about on the next couple of slides. But at the end of the day, you need to think about security in a different way. And this is also then the reason why we're here today. Maybe these new technologies are actually like in conflict with internal or external security or compliance requirements. So you may have something within your company as of right now that states you need to do that. You need to monitor traffic, for example, at every single point of the network, which is maybe not possible anymore because you actually don't know where your workload is being processed. It could be server 4, server 6, server 700. You don't know it. It's kind of hard for you to monitor that if that's like an internal compliance requirement or an internal security requirements. And this is basically the problem we are facing today with microservices and PCI. To summarize this, I think this sentence would describe it perfectly, that technology generally just advances faster than compliance frameworks. And we saw that in the PCI 4.0 timeline earlier. We received like the first initial draft in October 2019. And we will assume that in October 2023, that will be applicable. That will be the new compliance requirement. And there was development of that requirements before October 2019. So maybe 1 year, maybe 2 years. So we are looking at some kind of 5-year, 6-year cycle for PCI compliance frameworks to develop and to be updated and aligned to new technology. And maybe 6 years ago, I don't know who thought about using microservices within their production environment. Maybe you thought about it, but who actually used that? So I think we assessed the first microservices PCI environments probably in 2017, I guess. And this was the first, and now it's just coming up. But basically, you see the technology is there, and there's a 5 to 6 year cycle of compliance frameworks where they need to update, where they need to incorporate new technology, and that can be quite challenging, both for you and for us. So today, then we want to look at 3 major topics, and I think one would be like network security, which is really interesting within the microservices world. Basically GitOps, DevOps, infrastructure as code, and then some other thoughts on the whole security within the microservice world. So pointing out the one of the current requirements, the current requirement in the networking requirements, they always talk about firewalls. And as you already know, maybe, and if you saw the example I have given you earlier, there are no firewalls in the microservice. Although there are firewalls, but maybe they're not responsible for segmentation, for something like that. So it's here, it's in black and white. You can say to us, I'm not using a firewall, sorry. So this requirement is not applicable to us. And we are sitting here, we are reading the same requirement, and it's talking only about firewalls. So we need to always look at the intent of the requirement. We need to look at what is happening here and what would be the intention, what should be protected here. And this goes through all the firewall requirements. It's just not up to date. And this just here to basically point out the missing or the slow alignment to new technologies in the PCI requirements. It's actually good news that in the draft this was updated, and all the firewall requirements, they will talk about network security controls and not firewalls anymore. But let's look at, so network security controls could be something like software-defined networks, which microservices are using. And the software-defined networks will apply on different levels. So here we have an example, an OpenShift example, where we see 2 nodes, so basically 2 servers, and each has a pod running. A pod is basically like one or more containers that are deployed together as some kind of one entity in there. So we can call that maybe one microservice. And you can deploy all these pods on different nodes. We've seen that. So maybe this is node 1 and node 2 right now. In the next seconds, it could be node 1 and node 7, or node 11, node 22, whatever. So therefore, we know on the right-hand side, let me use the laser pointer here. On this side, where the basically physical network port is, we can't use a network appliance on that level to limit traffic between the different pods here, because we actually don't know where the traffic is originating from or where the traffic is actually going to, because as we said, the orchestration layer can always tell a pod to be started on a different node, on a different server. So we actually don't know, and we can't really map all possible scenarios. And also on the next slide, I will talk about the example of 2 pods running on the same node, which would also make this very complicated. So what the solution is, obviously, that we need a network policy that needs to be applied on an adapter that is basically running in software at an earlier stage, because we don't know where the network traffic is running. And so OpenShift in that case will be able to define network rules, ingress and egress rules on that interface. And we will take a look at this on the same node. So again, here we have no network traffic going through the basically network adapter of the node here. So no firewall in the world would be able to actually inspect or segment or restrict traffic between the two pods here, because traffic is just not flowing here. So we need to make sure the network policy between the two pods here, between the two microservices, would be configured PCI compliant at this level. So how would that look? We will take a look, and you obviously would use a YAML file in general to define the network rules, classical deny all rule. And then if here's an example, we want to have the semi pod here. We want to have allow that semi can speak to the NOA pod. And we don't know where semi actually, on which node semi is currently deployed. Maybe they're on the same pod, maybe they are on different servers on different nodes. We don't know. We need to make sure we define the ingress rule here. We need to then make sure we want to allow port 8080, for example. And so Sammy is now able to talk to NOA on port 8080, regardless of where that pod is running. So even if that pod would be running on the same node, that network policy would still apply. So this is very crucial, and that also means that you need to make sure that all these network policies are configured and deployed in a PCI compliant manner. And for example, they also need to be reviewed every 6 months as part of the general PCI requirement 1.1.7, which requires a firewall and router configuration review and rule set review. So right now you need to go in. If you have this microservice architecture, you need to also review the ingress and egress rules that you defined for all the pods out there. So that's not something that is going away. This is something that is within the intent of the PCI requirement. The good thing is here that you usually will have this in some kind of code repository. You could probably code something that can help you to identify all the ingress and egress rules, help you to identify all the changes. You can always usually should be able to see all the pull requests, all the changes to that network policies. So at least something that helps. Then as a question, let me just quickly check on the question. I need to, sorry. Is that filtering in a stateful way? That's a good question. I need to think about that, and I think it is, but I would need to double check that. It should be, I guess. The thing is, with all the orchestration technology, you could basically implement different software network technology as well. So within OpenShift, for example, you can say, I want to use OpenV, I guess it's called, from Red Hat as well. You will use a software-defined network by Red Hat within Red Hat's OpenShift, but you would be able to deploy a different software-defined network technology there that would integrate within your orchestration layer and would be then able to define ingress and egress rules, I guess. So you need to check the technology that is being used by your orchestration layer, and then I think you can answer that question. Okay, moving on here on a similar topic regarding network segmentation or segmentation in general. This is a concept that is available also in Kubernetes and in most orchestration technology I've seen. So I think HashiCorp would also be able to provide a service that is able to do this. And we within the PCI world, we always know we have 3 different scope classifications. We have systems that are part of the CDE, the card data environment, that is where card data is actually being processed, stored, or whatever. And then we have connected to systems that are not processing cardholder data, but are able to connect to systems within that CDE, or security impacting systems that would be able to impact the security of the CDE. And then if that's not the case, then we also have out of scope systems that are not directly connected to any CDE systems, but maybe are connected to systems or security impacting systems, but they are generally considered out of scope and don't need to be PCI compliant. So we could apply these labels, we could apply these policies to the different servers, and this would make sure that if we have something that is running like a web server that is used for receiving credit card data, for example, which would be part of the CDE, that if that container is shut down and needs to be redeployed on a different server, then it will only get redeployed on a server that has a CDE flag and CDE policy attached to it. Obviously, that container needs to know I'm a CDE container. And then the server needs to be flagged as well, so that can work. But at the end of the day, this is a possible solution for running like a mixed mode cluster. So if you have a lot of microservices that are not in PCI scope, you can use the policy flag here to make sure they will always spawn on a server that is not CDE and not connected to, so they won't be responsible for expanding your scope in that case. If that helps, this is a possibility. Now let's go through basically DevOps, GitOps, infrastructure as code approach, and within all that microservice world, Kubernetes world, cloud world also as well, a lot of you are moving to a CI/CD pipeline, DevOps pipeline, where everything you have is basically as code. And the question we get a lot is, within my PCI environment, do I suddenly have to enforce PCI DSS secure coding developments requirements like 6.3, 6.4, 6.5 to that code? And the short answer is no. The long answer, no, but maybe you should, because from our reasoning here is within the normal PCI environment, you would have an admin who would go to a server, would put his code there in shell, would deploy an application, whatever. This is all done by a single person. Obviously, there needs to be some kind of approved change for that, but on the system itself, the actual change will be done by a single person without 4 eyes principles. So that's not requirement. That's not required here, but you need to understand that the software development best practices can be applied to basically DevOps and GitOps way of life as well. So usually if there's a pull request to change some kind of networking policy, change some kind of Docker file, you want, I guess, to want to have a second person reviewing that, using the tools that are already available within GitHub, GitLab. It's just a common best practice. You maybe don't need that from a PCI point of view, but I think this would be a current best practice. Also, the pipeline itself, so all the tools we just saw, from Jenkins to GitHub Enterprise to GitLab to Terraform, whatever is used in there to make sure your production is actually up and running. All that we call the pipeline, and suddenly all that security is basically configured in the pipeline, and the security of your whole production environment is all only as good as the security within your pipeline. So that obviously means that we will have a PCI scoping impact, while in the past you easily could tell your production environment where the CDE systems are located, that this is there, this is PCI relevant, and you maybe have some connected to systems in there. You maybe throw in a security impacting system in there. But at the end of the day, suddenly you will have some kind of immutable infrastructure. You don't actually want to touch your production environment anymore. Maybe you actually can't. Maybe there's no SSH service baked in to your containers. Maybe you can't log in there at all. You can either throw away a container and start a new one, but there's no way to tamper with a up and running container. So suddenly all the security will go through to the pipeline, and you need to make sure that the pipeline is configured in a secure manner. So for example, if you have a Jenkins, and that Jenkins is basically like the central point of interaction for your DevOps guys and girls, you need to make sure your user management is in place. You should, if it's maybe available from the outside, maybe it's two factors needs to be applied there. Maybe you need to have some kind of approvers group within that Jenkins for people who can approve to production and not have automatic push to production after a pull request, a random pull request is completed. So there's a lot of security impact there, and that means we need to look at that during a PCI DSS assessment. I was already talking about that deployment approval, so maybe you need to think about it. Then if we want to talk about patch management, suddenly if you have the immutable infrastructure and you have a container up and running there, maybe as you built this one, this was up to date, but now you have a lesser used service, and suddenly that microservice, that container is running, that pod is running for 2 to 3 months, and there's no need to change anything. But in the meantime, there's a vulnerability, and therefore some of our customers are kind of rebuilding containers every 30 days to make sure they rebuild every container with the latest image. And so they have some kind of proactive way of handling vulnerabilities in that environment. Also, vulnerability scanning, like a classic PCI requirement. Suddenly you can use scanning on your registry, you can use runtime scanning, and yes, maybe that is sufficient for some here, but you would definitely help the security posture at the end of the day, but your nodes, for example, would not be scanned if you're still running the nodes by yourself. And obviously, if you have everything as code, you always need to think about your key and secret management, which will also be, I guess, a new PCI requirement in 4.0, where you need to make sure you don't include any secrets, any application passwords or application keys within your code, within the repository. You need to make sure you handle, obviously, the keys that encrypt and decrypt credit card data in a secure way. So there's a lot of stuff to think about if all the security is moving to the pipeline. And last but not least here, just some thoughts out there. I was already talking about the immutable infrastructure, and some PCI requirements require change detection, file integrity monitoring. Do you still need that? If you can prove to us, to your QSA, that your production environment is immutable and there's no way to change anything in there, what would be sufficient to show that you fulfill the change detection requirement there? Or if you go fully serverless and basically only have the application layer in scope, how can we do segmentation on that? And yeah, if we think about intrusion detection, we don't know. I have shown you the network setup. We don't know where traffic is. We don't know if the traffic is on the same node, on the same host. We can't really monitor that traffic at that point in time from the outside on the classical intrusion detection layer. So do we need to move to a host-based intrusion detection? Do we actually need that? So there are a lot of questions depending on your setup, depending on what kind of abstraction layer you're working with. There's a lot of to think about when using microservices and microservices cluster and orchestration technology. So thanks already for the first question I received earlier. If there are any other questions, I'm obviously willing to answer them right now. If not, I'm always available. Your QSA of choice should also be available if you want to reach out with specific questions. I think it's quite an interesting and complex topic, so it's not always easy to boil everything down to one or two questions. Maybe you actually need some kind of workshop where we can talk about your architecture and you will show us your solution and then we can take a look and see what kind of PCI requirements would be affected, how that would affect your assessment. Yeah. So I don't see any further questions. So maybe let's give you a quick heads up. We will try to publish our next webinar in a couple of weeks, and hopefully the topic will be web skimmers. This is something that is coming up a lot right now, and we will try to give you a quick update on the latest technology and techniques criminals are using, and maybe if SAQA in that case would be sufficient for compliance but not for security. So quite the interesting topic. And we will put this on the homepage very soon. And if you want to, you can always sign up to our newsletter, where you will be informed about any webinar that is upcoming by us or by another team. Also, any feedback in chat, via LinkedIn, via email is really appreciated. So we know you like the topics, we know you want us to continue on that. So thanks a lot. As I said, if you have questions, feel free to reach out. Thank you and stay healthy. Hope you had a good time. Hope you learned something. And yeah, hoping to see you again in the near future. Thanks.